So they showed that these constants actually were equal to 1 in the case of SON1 and SUN1, but they were interesting numbers, 2D minus 1 and 21 for the other two rank 1 semi-simple groups. And so a corollary of this observation concerns actions of these groups. It's a new invariant. No lattice. It turns out that the constant lambda g for a group is shared by all lattices in the group. It's not so hard to see. And, I guess I should say lambda g equals infinity if rank of g is greater than 1. So this is really only a rank 1 phenomenon. So this was, it was thought that it was going to be very hard to distinguish between lattice actions, especially in these symplectic groups. So again, I've done a little bit of work in this area. And I've shown that, in fact, yes, in the uniformly bounded. So a uniformly bounded representation means that instead of being unitary, where that equals 1, this is equal to a constant and maybe less than some constant. And I've shown that you can take the identity representation there. You can find uniformly bounded representations that go out towards the trivial representation in such a way that the norms of these representations approach 2D minus 1 or 21. So Michael and Uffe were only able to establish that for the spherical functions, and I've now shown it properly for the uniformly bounded norms of these representations. So anyway, maybe I shouldn't have spent 2 minutes on saying what I'd done, but I really wanted to sort of wrap up the talk by saying, look, we've seen ergodic theory on a lot of groups now. We've found a lot of invariants which enable us to distinguish between group actions. It's a really rich, fertile interplay between harmonic analysis and ergodic theory. I think there are a lot of good questions to be thought about and answered. And India, these questions are waiting for you. So thank you very much for listening to me over these times.
So perhaps we can take the questions after the break. So let's